Here's an example that talks about conditional probability. In a class of 25 students, 14 like pizza and 16 like iced coffee. One student likes neither and 6 students like both. One student is randomly selected from the class. What is the probability that the student A likes pizza and B likes pizza given that he or she likes iced coffee? So we've got two different scenarios here. We just want to isolate the liking of pizza, but then we can isolate the liking of pizza given that we already know something about them. So let's begin by demonstrating all this information with a Venn diagram. So I'll draw my Venn diagram and let's put a couple of circles in here. There's one, there's two. We can label some stuff here. I know that the pizza, we can call that one event, liking pizza, and then we could say iced coffee is another event. So there's a class of 25 students, so the sum of all of these values should be 25. 14 of them like pizza, 16 like coffee, one student likes neither. Well, and then 6 students like both. The neither, that's an easy one. Here I've got one student who likes neither, so they're not going to exist in any of these circles. And then I think the next easiest one to work with is 6 students like both. That means that the 6 will be the intersection of these two. So rather than write out all of the A plus B plus C plus D stuff, let's kind of puzzle our way through this. If I have a total of 14 who like pizza, and 6 of them already exist in the both category, then I must have a remaining 8 people in this only pizza category. And that kind of takes care of this pizza portion. And then 16 like iced coffee. So similarly, I must have 10 people who like only iced coffee, since 6 of those 16 are already accounted for. And let's just double check that this is a total of 25 students. So 8 plus 6 is 14, plus 10 is 24, plus 1 is 25. So far, so good. So let's determine the probability that this person likes pizza. And in order to figure that out, I need to take the number of people who like pizza. So the number of people who like pizza divided by the number of total elements in, we'll call this in the class. And the number of people who like pizza, that was given to us as 14. And that's out of the entire class, which is 25. And that's really it for this one. I can't reduce this, we're done. Next up, I want to find the probability that this person likes pizza given they like iced coffee. So what that means is I am beginning with the knowledge that this person likes iced coffee. So let me kind of shade what we're talking about in the Venn diagram. That means that I'm already inside of the iced coffee circle. I know that this person likes iced coffee, so I'm pulling a person out of this new area. So really, if I think about my new sample space, the sample space is 16. There are only 16 people that exist inside of this, this coffee region, iced coffee region. So the next thing then is I want to find out of those 16 people who likes pizza. And the pizza lovers are going to be inside of this intersection. These are the people who like pizza. So let me shade this as well. These are the people who like pizza and are given that they exist in that iced coffee area. So that's going to be given as 6, since 6 out of 16 people like this iced coffee. So I'm going to reduce that to be a probability of 3/8. Now let's just look at that using that probability law that we talked about before. We said that the probability of A given B is equal to the probability of A and B divided by the probability of B. Or in this case, I could say the probability of pizza given ice cream, or iced coffee, is going to equal the probability of pizza and iced coffee over the probability of iced coffee. Well, you can look that that's really the same thing that I came up with. The probability of being in iced coffee, or being in pizza and iced coffee, that's that 6. That's the intersection of those two things, divided by the number of people who just like iced coffee, and that's 16. So that's another way of coming about that 6 out of 16. So a little bit trickier with this conditional probability, but if you visualize with a Venn diagram, you might not actually need to use this law as it's written in this algebraic form. So why don't you try this example here. We've got a cupboard and we've got cans of soup and chicken soup, pumpkin soup and chicken soup. I would say draw pictures, diagrams if that's helpful to you, and find me these two probabilities. So pause the video and give this one a shot. All right, so here are the answers to U try 6. It was actually helpful to draw a tree diagram for this problem here. And one of the kickers is if you are twice as likely to take a can from the bottom shelf as the top shelf, you kind of have to recognize that that probability is going to be 1/3 and 2/3 there. And then once you're at that point, you can branch out your trees. And I'm interested in the diagrams that are written here. So take a look at this, give it a once over, and make sure it makes sense to you.